This is part 2 of the quadratic equations tutorial, and we'll be carrying on from where we left off in the first one. In the first one we discussed what is the discriminant. It's denoted by d and it's equal to b squared minus 4ac, and the a, b, c over here are the a, b, c's in a quadratic equation of the form ax squared plus bx plus c equal to 0. And we also discussed how the value of this discriminant tells us about the nature of the two roots of any quadratic equation. And I also said that if d is equal to 0, if it's equal to 0, you get two roots which are equal. Now, you could take the example 0, comma 0. These will be your two roots. Now, it may sound strange, but even though these are equal, they're different roots. Just remember that I told you in the last tutorial that any quadratic equation will have two roots, whatever happens. It'll always have two roots because its degree is 2. Similarly, a cubic equation will have 3 roots. Now, it doesn't matter if they're both the same, they're still going to count as 2 roots. Just know that, because often people say that if d is equal to 0, you get only one root. It's not true. You get equal roots. So I'm going to move on to how to solve a quadratic equation without using factorization or anything like that. Just directly using a formula and getting your two roots. And the formula is this: minus of b plus minus root of d upon 2a. Okay, so you're probably wondering, what is this plus minus? The minus b is pretty clear. It is this b over here, the a is here, and the d is this d over here. But the plus minus basically means that when you're solving, you're going to take two separate cases. In one of them, you're going to do minus b plus root d by 2a, and in a separate case, you're going to take minus b minus of root d by 2a. Why you do this? It's again the same reason that you need two roots. So from this you're going to get one root from each case. Another useful result over here is the sum of roots. The sum of roots, when you add these two over here, is equal to nothing but minus b upon a. While the product of the roots, the product when you multiply these two, you'll get c upon a, and you can easily derive these if you actually multiply it. You'll see if you do it. I'm not going to derive it here, but if you write down, you'll see this. So over here, the questions that you can be asked is, say you've been given an equation. It's x squared plus 2x minus y is equal to 0. Now you've been given nothing but that the fact that the product of roots, denoted by p, is equal to, say, 4. Now just substitute the value of p, it's c by a, is equal to 4. Now you also know from this equation that a is equal to 1. You can see that x squared is actually equal to 1x squared, so the a is equal to 1. So from this you can say that c is equal to 4. Now you need to find the value of y over here. Now also keep in mind that if you look at this equation here, just concentrate on this part of it right now, the plus c. Now c could be either positive or negative. You could say that c is 2, or you could say that c is minus 2. When it is minus 2, your equation will become bx minus 2. It become plus of minus 2, which will be minus 2. So c not only includes just this part, but it's the whole thing. it's this whole term over here. So similarly, when we say c is equal to 4, we don't we it doesn't mean that just y is equal to 4, but actually the whole thing, this whole term, which is minus y is equal to 4. So since minus y is equal to 4, y is equal to minus 4. And you could get a very similar question, but instead of sum of roots, it would involve product, sorry, the other way around. Instead of product of fruits, it would involve the sum of fruits. But I don't think in grade 10 ICSE they ask many of those. But I've told you these formulae, and I think these will come of use later as well. When you do math in grade 11, these are used pretty often. Often in algebra, you have uh, these expressions, like in like grade 7 or 8, you would have done a plus b whole square. When you expand it, what you get? Similarly, a minus b whole square, a plus b into a minus b. These you should know by now. Uh, but there are a few more. Specifically for this chapter, they come in use a lot. So I think you should know these. Uh, I don't think I can tell you all of them, but I'm just going to list them down. Beyond that, you could see it for yourself. And also, if you don't like to just memorize them, uh, if you really want, then during the exam, you can actually sit down and expand it yourself. For example, a plus b whole cube would be nothing but a plus b whole square, which is here, which you should know by heart by now, into a plus b. I mean, this is easy, you could solve it even during the exam. But when it becomes a little bit bigger, say a plus b plus c whole square. Now, if you sit down and expand these during your exam, you're going to waste a lot of precious time. So I'd suggest that since these results come in use a lot, especially in this chapter, you should try and learn them before. But if you can't, that's fine. You can expand on the spot. And also the last one would be a cube plus b cube plus c cube. So that's it really for the theory bit. I'm just going to do a few questions. I don't have much time left in the tutorial, so I'll do one quick one. So there's this question which came in the 2007 paper. Very straightforward, just a few calculations required. And you just need to directly apply the formula that I told you. This is the question. Solve the following quadratic equation for x and give your answer correct at 2 decimal places. And the equation is given as x squared minus 3x minus 9 is equal to 0. So I think the first thing that you should do in these type of questions is actually figure out what is a, what is b, what is c. So you can see that a is equal to 1. In most of your questions, a will be equal to 1. B is equal to minus 3, you could see here, and similarly C equal to minus 9. Now, just apply the formula. I think it'd be better if you take out D first, the value of D. That's B squared minus 4AC. So just substitute the values. So you get 9 minus 4 into A, which is 1, into minus 9. So this is equal to 9 minus 4 into minus 9, which is minus 36. So this becomes 9 plus 36, which is 45. Now, let's just apply the formula now. So minus b plus minus root of d upon 2a. Minus of b is 3, plus minus root of d. D we got is 45 right now. And don't worry if you don't get a perfect square over here in these questions. you're not really meant to, which is why they say solve uh, up to 2 decimal places, because you won't really get a whole number here. And in the denominator we get 2a, so a is 1, so we get 2 over here. Now I'm not going to do the calculations, or why not actually. Where's the calculator? So root of 45 is 6, let's take it as 6.7. So remember, you have to write two cases here because you get two answers. We'll continue it here. 3 plus, what is it? 6.7, let's round it up to 6.71. We've been asked to solve up to 2 decimal places, and usually when it says that to be safe, you should always solve up till 3 first and then round it off to 2. So say you've solved it up to 3 and you get 6.708. What you do is just round this off, and I hope you know how to round off. So when you round off, it comes to 6.71. So 3 plus 6.71 upon 2, and the other root is 3 minus 6.71 upon 2. And when you solve this, you get 9.71 upon 2, and you get minus 3.71 upon 2. Solve these further, we get 4.8, what do you get? 4.85, and the other one will be minus 1.85, and again I'm rounding off over here. This will not be exactly it, this will actually come out to be 9.7, but I've rounded off. Just to show you, make it a bit more clear, 9.71 upon 2, 4.855. So you just ignore that 5 for now, we need only 2 decimal places. I guess you could, if you really want, you could write 4.855. I think you should do that just to be safe. Even over here it will come similarly, minus 3.71 divided by 2, minus 1.855. But usually in the last step you should ignore this. It says 2 decimal places, but you're not going to lose any marks if you write the third one as well. So I suggest, to be safe, write the whole thing. But when it says 2 decimal places, always solve till 3, especially this root over here. Solve till 3 and round till 2, and then you should be fine. There are many other questions like these, and I can tell you that this is a very common question in section B. In section B, you have 10 mark questions, and they all have 3 parts to them. And this usually comes as either a 3 mark question or a 4 mark question. So it's very scoring, and I mean, there's nothing really to it. All you need to know is this formula here, and you need to know how to find the square root of a number. I think that's it for this tutorial. I'm going to continue this with a few more questions on the topic in the next one.